Good afternoon. My name is Bob Muro, and we're here at IMS 2026, and we're Maury Microwave, and we're showing our satellite link emulator and how it can model imperfections in your payload. And we'll see this reflected in changes to what a perfect constellation would be like. We have a vector signal generator that's generating a carrier signal, 1125 megahertz. It's generating a 64 QAM or quadrature amplitude modulated signal, and we're decoding it in our vector signal analyzer over here, and you can basically see the constellation points. And ideally, it's 8 by 8, and what you need to see is kind of a pinpoint in the constellation diagram. So when this thing is sampling at a thing called the symbol rate, you see a perfect constellation. We're going to disturb that using an ACE. You'll see here that we have a perfect constellation, but what we want to do is distort this in a specific set of conditions. So using our ACE, we're going to be able to distort this in AM, PM, or no AM at all, and we'll explain the differences and what you should see reflected on the constellation. This is our Maury GUI client. So we have a client-server relationship between the ACE and any standard Windows operating system laptop. And you might not be able to see it, but we've connected here. So we're talking to it via Ethernet. And what we're going to do today is we're going to look at nonlinear behavior of your hardware in the loop, or what they refer to as your payload. Okay, so what we're showing is essentially a perfect constellation. So you see all the points are very small, and that's what we'd expect from a very clean channel. But what we want to do is we want to see what happens when we purposely distort it. That's something that could actually happen to your hardware in space. So our first look is AM, PM distortion. So you notice that there's rotation, and there's also AM modulation, and you'll see that the corners are a little bit shrunk. So we can see that we've clearly distorted this with AM, PM collectively. Next, we're going to go strictly with PM. So all we're getting is slight rotation out of this, and you can see that reflected in the constellation diagram. And now we're going to go with just straight AM, and you'll notice that the corners are completely compressed. So you can see that, and that is illustrated by the different constellation, the different shape change in the constellation. So if we go back, now you can remember that's a perfect constellation, but we want to model AM, PM, AM, and PM separately. So as you had seen reflected with the test, we distorted the communication channel with AM only, PM only, and then a combination of both. And it was easy to see graphically how this affected the constellation diagram. And this is a normal mode of communication testing for a standard RF test engineer to model the wireless channel. And if you would like to know more about our ACE, we have a lot of data and data sheets and manuals at MauryMicrowave.com. So it's MauryMW.com. And you can go there and you can find this. You can also contact our support lines, and we have application engineers more than happy to teach you all about ACE and how to use it.